In the deep silence of the early solar system, a new world begins to stir from the wreckage of creation. Gravity exerts its relentless pull, dragging fragments of rock and ice into a growing celestial body. This is the pre-Noachian era, a time of extreme heat and planetary forging. Heavy elements sink toward the center, forming a dense and spinning metallic core. Around this core, a rocky mantle and a thin, fragile crust begin to stabilize. Volatile gases trapped within the rock begin to hiss upward, creating the first breath of an atmosphere. Within just a few million years, a thick blanket of carbon dioxide and water vapor wraps the planet. From the heavens, icy comets descend, carrying the precious gift of water to the surface. As the planet cools to a hospitable temperature, the first rains in Martian history begin to fall. Endless downpours fill the lowlands, carving the first rivers and gathering into vast basins. A massive ocean begins to take shape, eventually covering 1/3 of the entire northern hemisphere. The water is fresh and deep, shimmering under a sky that looks remarkably like our own. At this moment, 4.4 billion years ago, Mars was a world of blue and white. It was a twin to Earth, perhaps even more hospitable than its larger sister. The greenhouse effect traps the sun's warmth, maintaining a stable and pleasant climate. The dense atmosphere provides the pressure necessary for liquid water to persist for eons. In these quiet depths, the chemical building blocks of life begin to swirl together. But the peace of the pre-Noachian is a fleeting moment in cosmic time. Far out in the solar system, gravity is shifting, sending a barrage of rocks toward the inner planets. The era of heavy bombardment is about to begin, shattering the tranquility of the blue world. Giant impacts strike the crust, throwing millions of tons of debris back into the sky. The oceans boil at the points of contact, sending massive steam clouds into the stratosphere. The sky thickens with soot and ash, plunging the planet into a long volcanic winter. Yet, even in this violence, Mars remains a world of energy and potential. Underneath the chaos, the planet's magnetic field is at its peak strength. This invisible shield deflects the solar wind, keeping the atmosphere safely in place. The crust begins to buckle under internal pressure, giving birth to the first great Martian volcanoes. These volcanoes pump more than just heat. They release the minerals life craves. Hydrothermal vents at the bottom of the oceans become busy laboratories of chemistry. Could the first Martian microbes have been born here, safe from the impacts above? The planet is a vibrant engine of change, constantly recycling its surface. For hundreds of millions of years, the water remains, stable and inviting. Clouds drift lazily over the peaks, dropping snow that will feed the spring floods. The carbon cycle is in full swing, moving through the air, the water, and the rock. Mars is not just a rock, it is a living, breathing geological masterpiece. But every engine needs a fuel, and Mars' internal fire is starting to flicker. As the smaller planet loses its heat more quickly than Earth, the core begins to solidify. This internal cooling is the first domino in a series of catastrophic changes. The blue paradise is standing on the edge of a great transition. Beneath the surface of the water, a new kind of rain is preparing to fall, one that will change the chemistry of Mars forever. The calm waters of the pre-Noachian oceans begin to churn as the planet's internal heat reaches a breaking point. Far beneath the crust, tectonic pressures forced the first great Noachian volcanoes to erupt with cataclysmic force. Fountains of fire spray hundreds of meters into the thick, carbon-rich atmosphere. Rivers of molten rock carve deep, glowing scars across the pristine Martian plains. Massive clouds of sulfur and ash billow outward, blanketing the entire planet in a suffocating shroud. These volcanic gases trigger a powerful greenhouse effect, trapping the sun's warmth within the air. High above the chaos, moisture begins to cling to the drifting particles of volcanic dust. The sky darkens further as the first true storm systems of the Noachian era take shape. Static electricity buildup within the ash plumes ignites flashes of purple lightning. Then, the clouds finally break, and a torrential downpour of acid rain begins to fall. This rain is not life-giving water, but a corrosive cocktail of sulfuric and nitric acids. As the acid hits the basaltic crust, it triggers a violent chemical reaction, dissolving the rock. Minerals that had been locked away for eons are suddenly released into the flowing water. Iron, phosphorus, and sulfur create a rich chemical buffet in the expanding lakes. In these warm, nutrient-dense pools, the building blocks of life find a perfect nursery. For a few million years, Mars is a world of vibrant, albeit acidic, potential. Yet the very volcanoes that warmed the world continue to dump millions of tons of debris into the air. The ground shakes constantly as the planet's crust groans under the weight of new lava fields. Microscopic organisms may have already begun to harness the energy from these thermal vents. These early Martians would have thrived in conditions that would be lethal to most life on Earth. Above the surface, the landscape is a masterpiece of geological violence and beauty. But the core of the planet, the engine of all this activity, is beginning to change. The swirling liquid iron that generates the magnetic field starts to slow its rotation. Without this movement, the invisible shield protecting Mars from the sun begins to flicker. Solar winds, once deflected harmlessly, now begin to graze the upper reaches of the atmosphere. On the surface, the sky begins to lose its vibrant orange hue, turning a pale, dusty pink. The loss of heat-trapping gases means the temperatures start a slow, relentless decline. Volcanic eruptions become more sporadic, unable to keep pace with the escaping atmosphere. The great rivers that once roared through canyons begin to slow to a trickle. Salt flats emerge where vast lakes once mirrored the Martian moons. Microbes in the sediment must adapt to the rising salinity or face extinction. Each day, the sun's radiation becomes more direct as the air thins out. The once protective clouds are now thin wisps, unable to stop the radiation from reaching the ground. Deep within the planet, the last remaining heat is struggling to keep the core active. If the magnetic field fails completely, the planet's atmosphere will have no defense against the solar wind. The chemical buffet that sustained early life is slowly being buried under layers of dust. A final, massive volcanic event attempts to jumpstart the planetary engine one last time. The ground tears open, but instead of life-giving warmth, it releases only more toxic fumes. The balance between a living world and a dead rock is tipping toward the void. As the magnetic field reaches its lowest point in history, a massive solar flare is detected heading straight for the defenseless planet. Deep beneath the Martian crust, the churning heart of the planet begins to lose its ancient rhythm. For millions of years, this liquid dynamo had generated a powerful magnetic shield around the world. But as the planet's smaller mass radiates heat into the void, the core starts to solidify. The convection currents that once powered the magnetosphere slow to a sluggish crawl. Above the surface, the invisible lines of force begin to flicker and snap. Without this shield, the planet lies completely exposed to the wrath of the sun. The solar wind is not a breeze of air, but a torrent of high-speed charged particles. These particles strike the upper atmosphere with the force of a cosmic hammer. Upon impact, the solar wind strips electrons from the air molecules, turning them into ions. These newly charged ions are caught by the sun's own magnetic field and dragged away into space. This process, known as atmospheric sputtering, begins to bleed the planet dry. On the surface, the sky begins to change from a vibrant blue to a hazy, dusty violet. The pressure that once kept the great oceans stable is slowly vanishing. Without a magnetic field, the surface is now bombarded by lethal cosmic radiation. For any life forms thriving in the shallows, the world has suddenly become a radiation oven. The greenhouse effect, which kept the planet warm, falters as the carbon dioxide is swept away. Temperatures begin a slow, agonizing descent toward a permanent deep freeze. The core of the problem remains hidden thousands of kilometers below the feet of any observer. Once the planetary engine stops, there is no way to restart the warmth. Mars is essentially a smaller vessel that has run out of fuel too early in its life. As the air thins, the water on the surface begins to sublimate directly into gas. The great rivers that carved the valleys of Marineris begin to choke on their own silt. The sky is no longer a friend, but a window to the vacuum of space. Every solar flare now acts like a giant celestial vacuum, sucking up what remains of the Martian air. The blue marble of the past is fading into the red desert of the future.
Scientists estimate that Mars lost most of its atmosphere during this critical period.
Without the weight of the air, the liquid water can no longer exist on the surface at all. The music of falling rain is replaced by the whistle of dry, abrasive wind. Yet life is stubborn and does not give up the ghost so easily. They seek the last remnants of warmth trapped within the planetary crust. This collapse of the magnetic field was the single most catastrophic event in Martian history. It transformed a world that could have been Earth's twin into a cautionary tale. The iron in the soil begins to oxidize, rusting the entire world into its signature hue. The oceans are now just ghost memories written in salt and sand. The atmosphere is now so thin that the sun's rays offer no warmth, only radiation. The loss of the shield means that the very air becomes a weapon against the planet. The era of the blue sky is officially coming to a permanent end. But even as the surface dies, a new and stranger period of Martian history is about to begin. The Hesperian transition will see the planet's final, violent attempts to hold on to its life. As the magnetic field reaches its lowest point in history, a massive solar flare is detected heading straight for the defenseless planet. The solar flare strikes the upper atmosphere with the fury of 1,000 nuclear suns. Without a magnetic shield, the defenseless air molecules are ripped away into the dark void. This marks the beginning of the Hesperian period, a time of profound planetary transition. For a brief window in cosmic time, Mars looks remarkably similar to our modern Earth. Large northern oceans still ripple under a sky that has not yet turned eternally red. Deep within these waters, single-celled organisms engage in a silent struggle for existence. At this exact moment, Earth is also fostering its first sparks of primitive life. But the two siblings are on diverging paths as the solar wind continues its invisible theft. Every second, tons of precious oxygen and nitrogen are lost to the cosmic graveyard. As the pressure drops, the once warm surface begins to feel the first bite of an eternal winter. The water that does remain becomes increasingly briny and heavy with dissolved salts. These brines are the last sanctuaries for the hardy microbes on the surface. Volcanic activity remains high, acting as a temporary savior for the dying atmosphere. Giant plumes of carbon dioxide and sulfur are pumped back into the thinning air. These eruptions provide a fleeting greenhouse effect, delaying the inevitable freeze. But the solar wind is a persistent thief that never stops its work. The sky begins to shift from a pale Earth-like blue to a hazy, dusty pink. Fine dust particles, lifted by growing winds, start to hang permanently in the air. Massive rivers that once carved the landscape begin to slow into a trickle. The sound of running water, once a roar, is now a faint whisper against the rocks. This is a planet in a state of slow-motion collapse. Beneath the drying surface, something else is happening. Chemical reactions between water and volcanic rock create pockets of energy. Life is not giving up. It is simply retreating into the darkness. On the surface, the beauty of the Hesperian era is a tragic one. The atmosphere is now only half as thick as it was during the Noachian. Each solar storm acts like a giant vacuum, sucking the lifeblood out of the world. Lakes that were once vibrant and deep become shallow, stagnant ponds. The lack of air pressure means water begins to evaporate even at low temperatures. Large-scale flooding still occurs, but these are now violent, chaotic events. These floods carve the gargantuan channels we still see on Mars today. They are the final, desperate gasps of a hydrological cycle that is failing. By 3 billion years ago, the transformation is almost complete. The Northern Ocean has vanished, leaving behind a vast, frozen wasteland. The air is now too thin for liquid water to ever exist comfortably again. Radiation from the sun begins to sterilize the top layer of the Martian soil. Any life left on the surface is being burned away by the very star that once nurtured it. But deep in the Jezero crater, a final secret is being buried in the mud. These sediments will wait for billions of years for a visitor from another world to find them. Suddenly, the ground begins to shake with a force never before seen in this era. A massive plume of ash rises from the horizon, far larger than any previous eruption. The final transition to the Red Desert is about to be accelerated by a geological monster. As the sky turns pitch black from the ash, a strange, rhythmic clicking sound echoes from a nearby cave. The rhythmic clicking from the cave grows louder as the modern era of exploration begins. Millions of miles away, a complex machine prepares for its most critical descent yet. The Jezero crater awaits, holding the dry remains of what was once a massive river delta. The Perseverance rover touches down, its wheels biting into the fine crimson dust. It begins its journey through Neretva Vallis, a dried-out canyon where water once roared. Scientists on Earth watch through the rover's eyes as it approaches a strange formation. A specific rock catches the light, displaying odd pale patches across its surface. These are the leopard spots, small chemical signatures that hint at a biological past. The rover extends its robotic arm to perform a detailed chemical analysis. Instruments detect the presence of organic molecules, the very building blocks of life. Iron-rich minerals like vivianite and magnetite are identified within the spots. On Earth, these exact chemical patterns are almost always created by bacteria.
Could these be the fossilized remains of Martian microbes from 3 billion years ago?
The rover prepares to take a core sample, drilling deep into the heart of the mystery. A small cylinder of rock is extracted and sealed inside a titanium tube. This precious cargo will one day be returned to laboratories on Earth for final proof. Until then, the rover continues its lonely trek across the desolation. It passes by ancient shorelines that have been dry for billions of years. The wind begins to pick up, carrying a fine grit that scours the rover's chassis. A massive dust storm is forming on the horizon, threatening to halt all operations. Commands are beamed from Earth to put the rover into a safe standby mode. The machine lowers its head and waits as the sky turns a deep, bruised purple. In the silence of the storm, the leopard spots on the nearby rocks seem to pulse. This chemical feast was once the epicenter of a thriving ecosystem. The minerals formed as water interacted with the volcanic basalt of the crater floor. It was a moment in time where two worlds were nearly identical in their potential for life. But while Earth's life flourished into complexity, Mars's life was cut short. The rover's sensors detect a sudden drop in temperature as the storm peaks. A sharp metallic ping echoes through the rover's frame as a piece of debris strikes it. Back on Earth, the signal from the rover begins to flicker and degrade. The harsh reality of the red planet is a constant threat to our robotic emissaries. Yet, even in this wasteland, the secrets of our origins remain preserved. To understand the spots is to understand if we are truly alone in the universe. As the storm subsides, the rover's solar panels catch the first glint of the sun. A weak but steady signal reaches the giant radio dishes in the Australian desert. New data starts pouring in, revealing even more complex structures within the silt. Near the edge of the crater, a strange opening in the rock is revealed by the wind. It looks like an entrance to a subsurface cavern, untouched for eons. The rover's internal sensors pick up a faint, rhythmic vibration coming from deep within the ground. Far below the surface, where the heat still lingers, something ancient is stirring. As the rover turns its camera toward the cave, the rhythmic clicking sound from the previous era returns, but this time, it's coming from inside the machine's own transmission. These volcanic eruptions are a double-edged sword, poisoning the air while providing the warmth necessary for life to cling on. Suddenly, the rust-colored horizon dissolves, replaced by a vibrant, deep cerulean sky that stretches across the Martian firmament. We have stepped back 3.5 billion years into the Hesperian period, a time when Mars was a twin to the early Earth. The sound of dry, whistling wind is replaced by the gentle, rhythmic lap of water against a shoreline of dark volcanic sand. Here, the atmosphere is thick enough to support liquid water, though it remains a deadly cocktail of carbon dioxide and volcanic gases. A massive river, the Neretva, roars through the valley, carving deep into the iron-rich bedrock and carrying silt toward the delta. High above, thick clouds of water, ice, and carbon dioxide drift lazily, casting long shadows over the rugged terrain. To a human observer, the scene is hauntingly familiar, yet there is a profound absence of green, for life here is still invisible to the naked eye. Beneath the surface of these rushing waters, trillions of microbes are locked in a silent struggle for survival in a chemical-rich environment. This was the golden age of Mars, A brief window where the planet breathed and flowed before the Great Silence began. Yet, even in this beautiful moment, the signs of decay are already visible if one knows where to look. The Northern Ocean, once vast and deep, is already beginning to retreat, leaving behind miles of salty, encrusted flats. The blue of the sky is slightly thinner than it was a million years prior, a symptom of the dying magnetic field. Without that protective shield, the solar wind begins its invisible assault, tearing away the very air that keeps the water liquid. Every wave that crashes against the shore releases moisture that may never return to the surface again. In the distance, the silhouette of a young Olympus Mons rises, occasionally venting plumes of ash that stain the blue sky gray. If you were to walk on this surface, your boots would crunch on volcanic glass and mud, leaving tracks in a world that has never known a footstep. The silence of the landscape is total, broken only by the roar of water and the occasional thunder of a distant rock slide. Rainbows occasionally arch across the sky after heavy rains, their colors vivid against the darkening Martian clouds. These rains are acidic, carrying dissolved minerals that turn the riverbeds into a vibrant palette of reds, yellows, and oranges. But as the sun sets, the temperature drops with a ferocity that hints at the frozen future awaiting this world. The two moons, Phobos and Deimos, appear larger and brighter in the thick ancient air than they do in the modern thin atmosphere. In this era, Mars is a place of possibility, where the building blocks of complexity are all present and active. However, the clock is ticking, and every second the core cools, the planet's heartbeat slows just a little more. The great floods that once carved the landscape are becoming rarer, replaced by seasonal trickles as the water table begins to sink. The blue sky is a beautiful lie, a temporary mask over a world that is fundamentally destined for desolation. Scientists wonder if the microbes in these ancient waters ever sensed the coming change, or if they simply lived in the moment. The atmosphere begins to shimmer again, the blue sky flickering as the vision of the past starts to fail. We must look closer at the rocks beneath our feet, for they are the only witnesses that remain of this vibrant era. The leopard spots we saw in the modern crater were born here, in the chemical reactions of this ancient wet world. As the vision fades, the rushing rivers fall silent, their waters evaporating into the cold, thin air of the future. For a few million years, Mars was the crown jewel of the solar system, a paradise of blue and silver. But the Hesperian transition was a period of extreme loss, where the planet's very soul was stripped away by the sun. The life that thrived in the open air began to realize that the surface was no longer a safe haven. The beautiful blue skies are turning a dusty violet as the first great dust storms begin to brew in the thinning air. This journey to the past shows us not just what was lost, but how fragile the balance of a planet truly is. We are standing at the edge of a catastrophe that lasted 1 billion years. The distortion intensifies, the blue sky cracking like glass to reveal the freezing red desert of the present day. As the blue sky vanishes completely, a sudden piercing screech echoes through the rover's internal sensors, but there is no wind outside to cause it. The electronic screech within the rover's sensors signals a terrifying shift in the planetary environment. Solar winds begin to strip the last vestiges of the upper atmosphere with brutal efficiency. Without a magnetic shield, the surface is now defenseless against the sun's lethal radiation. The once vibrant blue ponds are evaporating into a thin, ghostly mist. Microscopic organisms that once thrived in the shallows sense the rising toxicity of their world. The heat of the sun no longer provides life, but only brings destruction to the cellular walls. Gravity pulls the heavy, mineral-rich brine downward through the porous volcanic rock. A slow, invisible migration begins as life follows the water into the dark. On the surface, the temperature begins a permanent and lethal plunge.
Rivers that once carved Grand Canyons are reduced to frozen ribbons of ice.
The pressure of the atmosphere drops so low that liquid water boils away instantly. Deep beneath the permafrost, however, pockets of liquid warmth remain. These underground aquifers become the final bunkers for Martian biology. Here, protected from the ultraviolet rain, the microbes find a rhythmic peace. But the surface above is transforming into a world of endless dust storms. Static electricity crackles through the grit, creating miniature lightning bolts in the sand. The last of the Martian rain fell millions of years ago, never to return. The chemistry of the soil turns acidic, flavored by the sulfur of dying volcanoes. Any life left on the exterior is bleached white by the unrelenting radiation. This is the era of the Great Dying, where the biosphere shrinks to a fraction of its size. The underground refugees must now adapt to a diet of pure minerals and chemicals. They learn to breathe sulfur and eat iron, becoming rock dwellers in every sense. Above them, the iron in the dust begins to rust, giving Mars its iconic crimson hue. The sky, once blue, is now a permanent, hazy salmon color. The silence on the surface is absolute, broken only by the howling of the thin wind. But the subterranean world is far from silent, filled with the groans of shifting tectonic plates. The microbes must burrow deeper to escape the creeping cold of the crust. Every meter they descend brings them closer to the planet's remaining internal heat. They are now prisoners of the dark, cut off from the sun forever. The surface has become a graveyard of dreams and dried up hopes. Suddenly, a massive meteor impacts the northern plains, shaking the entire planet. The shockwave ripples through the crust, threatening the fragile underground sanctuaries. Dust from the impact chokes the atmosphere even further, blocking out the sun for years. The temperature drops another 20 degrees, sealing the surface in a permanent tomb. In the depths, the microbes survive the tremors and continue their slow chemical dance. They have become the ultimate survivors, outlasting oceans and atmosphere alike. Millions of years pass in the blink of a cosmic eye as the planet grows colder. The Martian crust thickens, making the journey to the heat of the core even longer. A new sound begins to vibrate through the rocks, different from any tectonic groan. Deep in the brine, something much larger than a microbe shifts in the darkness, and the ripples grow into waves. We have arrived at the final threshold of Martian history, 1 billion years into the past. The ripples in the dark brine have settled, and the deep aquifers have become quiet tombs. This is the Amazonian era, a period of stagnation that has lasted for nearly 3 billion years. The vibrant blue skies of the past have been bleached into a hazy, salmon-colored void. Average temperatures have plummeted to minus 60 degrees Celsius, locking the world in a permanent frost. The surface pressure is now a mere 1% of Earth's, making liquid water an impossibility. But even in this dying world, a Titan still stirs one last time. Olympus Mons, 3 times the height of Everest, begins its final eruption. It spews massive rivers of lava that stretch for hundreds of kilometers across the Tharsis Plateau. For a brief geological moment, these eruptions release greenhouse gases that warm the surrounding air. This is the planet's final, desperate attempt to reclaim its lost warmth. But the atmosphere is too thin to hold the heat, and the warmth quickly bleeds into space. The lava cools, the steam vanishes, and the silence returns to the Red Plains. Olympus Mons falls into a permanent sleep, becoming a silent monument to a more active past. The surface is now shaped only by the relentless grinding of the wind. A massive global dust storm begins to brew, swallowing entire continents in a shroud of red. The winds howl at hundreds of miles per hour, yet they carry no sound in the thin air. Beneath the surface, the last of the microbial life clings to existence in the deep geothermal warmth. They are the final echoes of a world that once rivaled Earth in its potential for complexity. As the core continues to cool, even these deep havens will eventually turn to ice. The story of Mars is a story of entropy, the inevitable winding down of a planetary clock. For the next billion years, nothing will change on this rusted sphere. It is a world of static beauty, preserved in the vacuum of its own making. From Earth, we look up and see a tiny red spark, unaware of the oceans that once crashed there. Our rovers now crawl across these ancient graveyards, searching for the ghosts of the Noachian era. We have found the chemical signatures of life hidden in the mudstones of a dry valley. This evidence tells us that we were not always alone in the solar system. Mars is our warning and our heritage, a glimpse into the fate of all rocky worlds. The billion-year journey from a blue paradise to a red desert is finally complete. The winds have died down, leaving the dust to settle on the massive shield of Olympus Mons. The stars shine with a cold, unwavering light over the Valles Marineris. Perhaps deep beneath the ice, a few resilient cells still wait for a warmth that will never return. Their existence is a testament to the stubbornness of life in a vast, indifferent universe. We leave Mars as we found it, a silent red sentinel in the dark. Its oceans are gone, its volcanoes are cold, but its story is written in every grain of sand. We are the witnesses to this planetary tragedy, the ones who give a voice to its billion-year silence. The great red world turns indifferent to our gaze. All conflicts between fire and ice, water and dust have been resolved. This is the end of the blue world and the eternal reign of the red world. The echoes of the past are finally still, leaving only the quiet beauty of the desert.